Hello, everyone. Thank you for joining today's webinar. My name is Nicole Markison, Digital Marketing Manager here at Ekahau. If you've joined one of our previous webinars, thanks and welcome back. If this is your first time joining us, we hope you find this webinar informative and insightful, and we look forward to having you join future sessions. Before we get started, I have a few quick housekeeping items. You're in listen-only mode, so your lines are muted. If you'd like to submit a question, type your inquiry into the questions pane of the control panel. You may send in your questions at any time during the presentation, and our subject matter experts will address them during the Q&A session at the end. Today's webinar topic is difficult Wi-Fi in warehouses and manufacturing facilities. Now I'm going to turn it over to Jussi, our Senior Vice President of Solutions Strategy and Customer Experience, to introduce our presenters and kick things off. Turning it over to you, Jussi.
All right, thank you, Nicole. Seem to be having some technical challenges there, but let's try the full screen mode again. Here we go, no spinning wheel of death. So can you see my screen okay?
Yep, we can see it.
Perfect, thank you. Thanks everybody for joining. Today we have a great webinar for you talking about difficult Wi-Fi in warehouse and manufacturing environments. Thanks again for coming. Today we'll be hanging out with Elizabeth and Francois. Elizabeth comes from VMware. Francois comes from Centio Networks, and my name is Jussi. Thanks for coming, guys. Just a couple of things before we let the subject matter experts hit it. First of all, about the agenda, we're going to talk about theory and practice and how they differ quite a bit in these environments. Talk about APs and antennas, compulsory interference, whatever that means. I have no understanding given that my English is bad. And we're going to talk about different kinds of clients, special clients in these environments, roaming. And then we're going to look at the kind of a live warehouse design example by Francois. So that should be exciting as well. And take my word for it, I've seen Elizabeth present some of this stuff before, and it's awesome. So it's going to be a good 1-hour session, I can promise you that. Real quickly before we kick things off. So for those of you that don't know Ekahau, and even for those of you that know us, this is what you have to explain to a lot of your peers these days. First of all, Wi-Fi is everywhere, right? Warehouses, hospitals, hotels, schools, everybody relies on Wi-Fi. And I wish you could see my awesome animation. But here, you know what happens when bad Wi-Fi happens. So just like Wi-Fi, bad Wi-Fi is everywhere. And warehouses grind to a halt, hospitals struggle if bad Wi-Fi happens. You know the deal better than anyone. It's just Wi-Fi is so critical. And why does bad Wi-Fi exist in the first place? Well, here's kind of the thing. Here's the Wi-Fi network life cycle, if you will. So when you deploy the network and move it directly to operations without, further thinking, the ideology and the promise is this, but the reality often is actually this. So when you straight deploy the network and only care about expansion and rebuilding when necessary, you run into tons of issues and troubleshooting, right? So here's an alternative. Here's like a life cycle for Wi-Fi that certainly works. So if you take some time to plan and validate the network before you deploy, it will be much more manageable. As my friend Lee Badman tends to say, if I design the network, I know the infrastructure is sound, so when problems happen, I can straight go and troubleshoot the client devices because I know the infrastructure is working. Okay, so there's a difference between bad Wi-Fi and great Wi-Fi, and the difference is this. Bad Wi-Fi is all these bad things, but what is great Wi-Fi? When things just work. And the justification really for Ekahau's existence is this. The world is freaking full of bad Wi-Fi, and our mission is to move everybody, or as many people as possible, from the dark side to the light. Does that make sense? Well, anyhow, that's what we do. But this is not a sales webinar. This is about the expert presenters. Before we begin, however, what's happened recently at Ekahau real quickly. First of all, the Boise Steve Ballmer, Joel Crane, CWNE, and an awesome guy, started with our company last week, I think, beginning of last week, as a sales engineer. Joel, congratulations, man.
Thanks, UC. It's great to be here.
Now, don't lie. You're suffering.
Only a little bit. No, seriously. Super. Thanks. I really appreciate it.
How was the first week?
It's been really great. I've had a lot of fun working with you guys, and looking forward to all the great stuff that's in store. So great product, great people to work with, great customers. It's just exciting all around.
All right, you'll get your $20 later for reading from the prompter, man. Also, I don't know how this animated GIF shows to you, but for example, so Ekahau is growing quite quickly, and we need help. So that's why we try to hire only the best, like Joel, and we have 3 great new developers starting next Monday as well. Developers. Anyhow, so speaking of Boise ball, so I was just thinking, maybe it's too back, but I was just thinking what would happen if we really had a Boise Balmer on the internet, and this is what I got. So I don't know. What do you think, Joe? So sorry for that.
Looks like I need to work on my hair a little bit.
You so do, man. Some tips for you, because that's exactly my hairstyle.
Oh yeah, that is your hairstyle, isn't it? Yeah, it looks good.
It is thin on the top, and then these curtains on the sides. Anyhow, we'll be at a great deal of conferences coming up early next year again. If you remember one of those, that's the Wireless LAN Pros in Phoenix. So really look forward to all of those as well. The Cisco conferences, Aruba, all that stuff. All right, but enough of my blabbering. One last thing I wanted to mention is our Ekahau Certified Survey Engineer training. It's a 4-day extensive training on how to design and maintain good Wi-Fi. We host like 100+ courses per year, and it's by some of these fine gentlemen, and you can also get those in French and auf Deutsch, auf Francois, and in Spanish. So yeah, go take one of those. Joel, you've taken one, right? Or not?
Yeah, no, I have. So yeah, no, I took the ECSE with Keith Parsons, and it was just fantastic. I highly recommend that.
Excellent stuff. I've seen him in action several times, and yeah, he's pretty good, to say the least. However, enough of taking your time. I'm gonna pass the ball over to Elizabeth. Before that, let's hook up. Find me on LinkedIn and Twitter. Just Google UC Wi-Fi, and you'll be able to find me. Elizabeth, you're still there, man?
I am here. Hello, everybody.
Thank you so much for joining. Much appreciate that. It was great seeing you in London the other day.
It was good to be part of the Wi-Fi family and be at the event. So hello, everybody. My name is Elizabeth Di Rocco. There's 2 of us presenting today. I will do the first part, and then Franca will take over. I will say a few words about me. I am a networking veteran. I was employed by Cisco for over 10 years. During the 10 years, I was in different roles, but throughout my career there, I was focused on wireless, primarily core wireless, so also a little bit of the emerging technologies, but mostly controllers, access points, RF, all that stuff. After I left Cisco, I have also done some other jobs, and as part of that, I did 1 year as the wireless planner for a large manufacturer in the UK. That's why I decided to present these slides as theory versus practice, because I've lived in both sides of the story. I've been a person working for a vendor, knowing the product very well, but not actually running the network on a daily basis. And I've also done the other side, running the network on a daily basis and having to deal with changes and deal with the actual real environment in a manufacturing setup. So I'm gonna let Francois introduce himself before I start over with my slides. Francois, are you there?
Yes, thank you, Elizabeth. So my name is Francois Burgess. I'm a Wi-Fi engineer. I live in Canada. I'm from France, and I work as I have my own company. It's called Sympheo Networks, and I just do Wi-Fi consulting. So I'm happy to be here, and I have done some work in warehouses environments. I personally really enjoy working in these environments. It's it brings a little excitement in my life rather than sitting at a desk. So I always enjoy working in warehouse environments, and plus people are usually very nice in those environments. So I'll let Elizabeth start with the presentation and interact a little bit with her. And then after that, I have a couple of examples to show the audience in Ekahau. And I'll show you guys how we can utilize Ekahau to design some specific warehouses environments.
Hey, Francois, you have your own podcast, don't you, as well, with Roel? You want to say a couple of words about that?
Yeah, thank you for the opportunity. You see, I co-host a podcast, a Wi-Fi podcast called Clear to Send with Roel Dionisio. So we try to publish one episode a week every Monday. So if you guys are interested in knowing what's going on in the Wi-Fi world, we talk about what's going on in the market. We interview people like you see, and we had Joel on the show as well. If you guys are interested, just go to cleartosend.net and you'll have all the information, and you'll be able to listen to all of the different podcasts. And we actually have a giveaway right now running because we hit our 100th episode a week ago. So if you guys are interested in winning some CWNP books, you can check it out at cleartosend.net/100.
Congratulations, man, and great podcast. You can find the URL to the podcast from the chat board. I'm sorry for taking some of your time, Elizabeth. Take it away.
No, that's okay. It's good to always advertise good wireless stuff. Okay, so let me start. So as I said at the beginning, I will try to talk about the theory and the practice and the contrast between them. And for every one of the topics that I'm going to talk today, I'm going to try to give you some lessons learned from me on the field. I come from a physics background. I did my university in physics, so I'm a big fan of the RF side of the house of wireless. And I've decided to just show you the topics that are relevant to that part, to RF design and the RF challenges and positioning of antennas and things like that in this presentation. So this is about what you see in the picture, right? Bridging that gap between what you learn in a classroom about wireless and what it actually is to run a mission-critical wireless deployment. Now, by mission-critical, I mean a network that cannot come down, or a network that will affect a lot the actual users, and it will affect businesses, not only a user just complaining, oh, I cannot get onto Facebook, but actually stop a manufacturing line and things like that if you stop that wireless. Okay, you see in editing mode, is that correct? I am on PowerPoint on full screen. Are you seeing full screen now, Joel? Can you tell me?
You are in editing mode, so try and... We can see the next slide now, but can you try full screen?
What about now?
Elizabeth, do you have two monitors by chance? Do you have dual monitors?
No.
Yeah, there's GoToMeeting sometimes has issues with the full screen mode, but that's totally fine. I mean, you can use the editing mode. We can certainly make things out of it.
Okay,
and just minimize that, and we're good. Here we go. Perfect.
Is that any better?
Much better, thank you.
Yeah, it's like the Ekahau product. It's not perfect, but good enough.
Okay. I'll do my best to. Apologies for that. I don't know why the Mac is doing that. So let me retrace my steps. So Running a mission-critical wireless deployment in a very, very complex RF is a bit of a challenge. And the main problem here is that the moment the wireless is stopped nowadays, it will actually can bring down your manufacturing line. So for example, if you have your logistics being done on handhelds and keeping track of your inventory, and those handhelds cannot report inventory usage or inventory arrival, you may end up with too much inventory or too little. And if you don't have enough pieces to build what you're building, you may really affect your manufacturing line, which will mean the company will lose money, which will probably mean you will lose your job as well. So running a mission-critical wireless environment is no joke. You have to be very careful on what you're doing, while at the same time you need to be as agile and quick as you can. So let's start. I'm going to skip a couple of slides that were supposed to be hidden. There you go. Let's start with my environment. So the manufacturing environment where I was working, it comprised of about 3,000 access points. This was an old Cisco house, but I'm pretty sure that if you're running any other vendor, you will have the same problems that I was having or the same challenges. So 3,000 access points, half of them were in office or kind of engineering sites. The other half was deployed in the actual manufacturing floor or warehouse kind of areas in the same locations. There was metal absolutely everywhere. I didn't have the challenge of having liquids in my stacking. So if you work for a retailer, you may have the problem of having liquids, juices, waters, things like that in your stacking. I didn't have that problem. It was pure metal everywhere where you walked. The structures were metal. What we manufactured was metal. The pieces were metal. Everything was metal. We had mezzanine levels on the manufacturing line. The manufacturing line will go up at some point, go around, move back down. You will have pieces flying above your head. You will have pieces on the floor, and the line continued to move and go back and forth all the time. So lots of mezzanine levels, and almost everywhere wireless was required. I was told once, everywhere that you can see a barcode, there should be wireless, because there will be a handheld scanner that will need to read that barcode, and that scanner will need to have wireless connectivity. So to be honest, everywhere I went in that plant there were barcodes absolutely everywhere. There were either boxes with barcodes for small pieces, or the big pieces will have barcodes attached to them. We will also have unpredictable racking. The racking will change almost on a daily basis. Sometimes we will have rows in one direction. The other day, rows will be in another direction. A week later, we will have islands of products one way or another. It was very difficult to predict in which direction we will have the gap, where the devices would actually be. We will have moving vehicles that includes trucks coming in and delivering parts. Also, forklift drivers moving all around, and even in spite of all the safety and security and training that you give them, they will sometimes hit columns or areas or something. So things happen when you have so many moving vehicles. We had extremely high ceilings, most of the time between 8 and 10 meters. So mounting from the ceiling was a problem. So most of the time we will mount on columns or stanchions. So the actual metallic columns that hold the building together. That was the best option. And there were, of course, safety and security constraints everywhere you went. So some areas you will have to have hard hats. Of course, safety shoes were required everywhere. So hard hats, safety shoes, high visibility jackets, and limitations on where you can move. So the wireless needed to go everywhere, but you as a human being were not allowed to go there to every little area that you needed. So most of the time I needed to work with somebody that will allow me, somebody from safety that will allow me to go and measure whatever I needed. So the good news that I had no liquids, I had no hazardous gases. I've also had to deal with that in the past, trying to deploy wireless in mines, and that was a big challenge because they had hazardous gases in the air. So at least we didn't have anything hazardous in the air there. And there was no need for high density Wi-Fi. So in the manufacturing floor, by definition, high density means one device or more per square meter. There's no way you reach that density in a manufacturing floor, at least in my environment. Distances were huge, and you only had, 100 handheld devices in 1 square kilometer, right? So it was definitely no high density in my environment. So coverage was key. So the topics that I'm going to cover are 4 of them. I'm going to talk about AP and antenna deployment and mounting in this kind of environments that I had experience with. I will talk about what I call compulsory interference. This is interference that you cannot move away from, that you have to have and you have to live with in your environment. I will talk a bit about the clients that I encounter and how they behave. And last but not least, about the fact that you cannot upset the status quo in such an environment. So let's go into AP and antenna deployment and mounting. And let's start with the site survey, right? Let's start here. This was my AP on a stick set that I had built. You have a tripod stand, a power supply that can be, well, in this case, I had in the picture a small switch with PoE, but much better than that is to use a power supply that is rechargeable, a battery kind of thing. In this case, I had to use that. 2 access points, one with internal antennas, one with external antennas, and my chosen antenna in this case was this dome antenna that Cisco provides, a high gain Omni antenna. In my case, as I said, there's no high density, so my goal was to provide coverage everywhere. In the office environment, the story is completely different. In the office environment, the engineering buildings, it was truly high density for me, so I had to deploy completely different RF there. But in the manufacturing floor, this is what I had. It was coverage. Now, my AP on a stick, and I can ask you guys the question, but I'm pretty sure you're all going to say similar things, is my AP on a stick had a height of up to 4 meters. That was the maximum I could mount this thing. Even I've searched online if I could find a kit that had higher antennas, and to be honest, I haven't found a kit that will allow me more than 4 meters of height. So this is how you test with the antenna at that height. If you need any higher than that, right, most of the time you need ladders, or even worse, you may need cherry pickers. It is very expensive to site survey with a cherry picker. I've done it. I've booked a couple of hours, and I know that it costs quite a bit of money to do testing at 10 meters of height with a cherry picker. You cannot go up there. You have to have a certified person that can do this kind of test for you. So I gave the guy the access point and the antenna, and I said, okay, put it this way. And then I tested on the floor. So keep in mind that your standard AP on a stick will have a limitation on height. The antenna is connected to the AP. The AP is powered. And of course, you need to wear safety shoes, hard hat, high visibility vests while you're performing the test. You're not always allowed to position the access points wherever you need. Sometimes you will have to make do with the locations when they say, okay, you can measure here, don't move over there, because if you break something, it's very expensive. So this is where you are allowed to go. So most of the time, I would be doing coverage tests in the environment and try to then replicate that coverage in the other areas. So I wouldn't do a full predictive survey. I would do a sort of predictive survey with my my kind of footprint of the antenna in a particular area where I could actually measure. Bear in mind that sometimes you will not be allowed to take pictures where you go, right? Because some of the manufacturing process may be proprietary. You don't want people to have any kind of information about what you're doing, right? So if you need to take pictures, sometimes you may need to ask for permission. So bearing in mind, yes.
Yeah, I just wanted to add something for the AP on the stick. I actually have been using, thanks to my good friend Gurpreet, he lended me a AP on the sticker that could go up to 25 feet. It's big, right? It has a big footprint, but in a warehouse, it's good, pretty good. I've been able to use it to mount an AP and go up to 25 feet. Otherwise, I've used in the past Skyjack, so I pretty much install the AP on a regular like painting pole and then attach it to the Skyjack, and then from the ground you can command raise the platform and then put it wherever you want it and then walk around.
Okay,
so
very good.
That might be some alternatives, yeah.
Yeah, so there are alternatives. Fantastic. I tell you, when I was trying to find the AP on a stick build this kit of the APN stick. There was no kit at the company. So when I was building this kit, I tried to find, and the best I could find was about 4 meters, and that was about it. So thank you for that.
And also
okay,
sorry, just one more thing. What I try to do as well when I do API on the stick and I have to walk around on the floor, I try to organize my survey with the team, try to see when they'll be working, when it's going to be busy. Sometimes I try to work when they're not working, if it's not like a 24/7 plant. So you're not disrupting their work, and everything you minimizing any safety problems.
Right. So it depends on the type of manufacturing processes that you have. This plant where I was a 24/7 for 24 hours a day for 6 days. So one day was off. So we could do some things during the weekends, but during the weekends, the plant will actually, the hallways will become storage area. So it was very difficult to do anything even then because it was all covered. So it depends on when you're working. Also, if the plant is completely empty and no moving parts and things like that, your RF may change. So it depends on how the environment changes, whether it is worth it or not to measure while things are offline. In my case, yes, we could do it when things were offline, and you're quite right. It was much easier. There were no moving vehicles around, so there's 3 times a year where they have shutdown periods for 1 week, and during that week, it was really a pleasure to perform surveys or to do any kind of RF testing because there was nobody there. There was no fear of a forklift driver just hitting you or your antenna or whatever. So you're quite right. If you have that option of testing off time, it's fantastic. Okay, so regarding cabling and AP mounting, now the considerations that we had in my case, and I think they're mostly universal. I always had to look out for my nearest cabinet. You have the limitation on Ethernet to power things and to communicate things, of course, of about 100 meters. You can play a little bit with that, go to 110, but it's not recommended. So, and deploying new cabinets, of course, costs money. You need to put power, you need to put the switch, you put all that stuff. So whenever possible, I will always have to make a note, okay, where is my nearest cabinet? How can I position things that my access point can actually utilize that cabinet? If there was an absolute requirement that I need a new cabinet, well, I would say, okay, you need a new cabinet here because otherwise you cannot get the wireless. But most of the time I did try to work with them and always follow where the data conduits were and where the cabinets were, just to make sure that my Ethernet was below that measure. The access point, we had to, of course, support this device. We need to have access to this device. It's an active piece of equipment. You need to sometimes get into console into that device if that device is failing, or even replaces if it's completely dead. So in our case, there was a requirement of saying, okay, the access point needs to be reachable without any kind of height, safety, whatever, testing for the person that is going there. So the rule was, do not mount the access point in the enclosure any higher than 2 meters. You can also decide, okay, well, we could console in all the access points, but console also has its limitations. And supposedly at the baud rate that you have in Cisco, that limitation is 30 meters. So you're even more limited by that. So if you want to console everything to a console switch, even that is a problem. So the compromise we did is we said, okay, let's just put the access point reachable for the engineers, and let's just try to work with the antenna. Now, cabling to the antenna, it's a bit of a problem because you don't want to go too far. You don't want to lose a lot of your signal on the cabling. So my recommendation was to keep it at most to 50 feet. You have longer cables, you have longer coax cables, you have 100, 150, but whenever possible, I would try to avoid those. Also, please try not to coil the coax cable because that will also affect your signal. So I've seen people use just 100 feet coax everywhere, and then whatever they had too much, they would just coil it on itself. And that, of course, is a bad idea with coax cable. Mounting the antenna, of course, you try to avoid metal, to put it at optimum height. If it is pole mounted, you put it on a pole. If it is ceiling mounted, you put it on a ceiling. But sometimes that is impossible. So avoid metal in a fully metallic environment. How do I do that? It's not possible. So you'll have metal. What you try to do is, in this case, in the picture that you see there, we would try to use these sticks of half a meter or a meter just to move away. And this actually, the picture that you have there is a beautiful deployment. It's a very easy one, but there were some of them that you would say so much metal around it, but there was nowhere else to mount the access point. So we tried to mount the AP a little bit away from these stanchions or away from all the rest of the cabling and pipes going around it. But it's not always ideal. So where the practice breaks the theory, right? We tested, as I said before, we always tested at 4 meters, but sometimes people would just say, with that antenna that we had, the high density, would say, okay, mount it here. And we had experience of people then say, okay, no, but that's going to be hit by a forklift driver. We just move it to 10 meters. So we tested at 4 and then just mount at 10 meters. And of course, the RF profile is completely different. Particularly for a high density antenna, they will mount a high gain antenna, they will mount it at 10 meters, and they have fantastic wireless at 10 meters of height. On the floor where the forklift drivers and the handheld scanners were used, the antenna, the signal was actually really pathetic in comparison to what you have above your head. So it's not good to test at 4 and then mount at 10. So if they tell you beforehand, you need to mount at 10 meters of height because there's no other choice because we're going to hit that, then you know to use a different antenna. And when you're testing the coverage, well, you're going to have to use a cherry picker or something, or a pole or something to get to that height and do the coverage test that way. I've seen people, because the network cabinet was at more than 100 meters away, they just used by default 100 feet coax and they try to reach the locations that way. Much better just put another cabinet nearby and do a better deployment. I've seen situations where an antenna, well, the one in the picture, an antenna has been positioned in the stanchion, but on the side where the drivers go by, and they actually turn around the corner there. There's 4 sides to this stanchion, so the cabinet, the enclosure with the antenna could have been put on the far side, and it wouldn't have been hit. But this particular enclosure, this IP65 enclosure, has been hit many times, and they just sellotaped it back together. So whenever you are, and let's go now into the lessons learned, whenever you are performing the survey, just work with the people that are local, that they know how the plant works. I did one of the big surveys that I did in this manufacturing floor. It was a deployment that would require around 14 UAPs on top of what they had. And I did this walk with this guy who knew the data conduits. He knew where every cabinet was there, where every data conduit was running, and he knew how the plant operated. He was a veteran of this plant. He had been working there for more than 10 years, and he knew exactly what the hazards were. So I worked with him. We did the documentation for mounting the new IPs, and I'm sure that deployment, which hasn't happened yet, that deployment will go without problems. They will not have to move things around. They will be able to follow it as the documentation says, because I work with them. I have other cases where we commissioned a site survey from somebody else. The guy came, he put the access points in areas, and then when they did the deployment, they just put them whatever else. So 3 locations, and then 3 locations recommended, and the 3 locations where they actually mounted is just completely different because they couldn't mount where this guy's was recommended. So whenever you're doing a survey or determining areas where to mount on a manufacturing floor, work with somebody who knows the area very well and knows the cabinets and conduits. If you need to mount a piece at any higher than 2 meters or anywhere that is not easily reachable, you may have to sacrifice an SLA for the IT team, because you may have to warn them, okay, if you mount this access point at 10 meters of height, then I will need to ask for a cherry picker. I will not be able to service this in, I don't know, 2 hours. So it's a compromise, right? If you have no other option but to mount an AP any higher, or to mount an AP in a location that is not easily reachable, then you'll have to sacrifice your SLA. If you're forced to mount the antennas at 10 meters of height, make sure that you have the right antenna. There may be other options. You may be able to position antennas at the far end of a corridor and put directional antennas down a hallway. Not easy in my case either, because racking will just change. But that may be an option. Another option is to mount, if the height is high enough, if you have this height of 10 meters, you may be able to use a directional antenna mounted on the ceiling pointing down. That may give you better coverage than high gain antennas positioning too high. So think about that as well. And try to use the shortest possible coax cable. Try to work with the deployments of the antennas when you're doing your triangles, building your coverage with your access points. try to position things so you can use the shortest coax cables possible. So it is a balancing act, definitely. Now, let's move to the next topic. And I will talk about compulsory interference. And by compulsory interference, I don't mean what you have in that corner. That, what you see in that picture, that's a jammer. If you see a jammer, you disconnect it. There's no question about it. If you see anything that is not supposed to be there, you will disconnect it. But in this case, I am talking about things like this. And Francois, have you seen that the one at the top, the horned beast at the top? It's a WireNet device. Have you ever seen that in a manufacturing environment or anywhere else?
No, actually, I've never seen this guy.
You've never seen that guy. What about the other one, the one on the left, that small round white one?
No, I've seen the video cameras. Yeah.
You've seen the video cameras, okay. So the two white ones at the top I had in my environment, they were WireNet devices. They're a zero resolution for location of whatever, right? Of location of, you put tags on things and you can locate your goods, your manufacturing goods, your supplies as well, people, whatever you want to track. So it's a location system by Zebra. It has this kind of tags, and it is running on 2.4. And this system was an overlay system, completely unrelated to my wireless, and it lived there in that environment. According to the people, they wanted to decommission it, but well, while I was there, that network was there. So WireNet was part of the manufacturing plant. Wireless video cameras, some cameras will operate on 802.11, but some of them not. Some of them will transmit on 2.4 or 5, and it will be completely proprietary protocol. So wireless video cameras will be there, and if nobody asks the wireless people, they may just deploy them, and they will cause interference. Now, you cannot just go and rip them. That's the problem, right? You can work with the teams and tell them, hey, look, you put these wireless cameras there, they're on my RF spectrum. But on the other hand, you cannot just rip them. The same thing with the WireNet network that I had. The other thing that I had were parallel wireless systems. So there was not only one Wi-Fi, there were areas where you would have some other Wi-Fi. And I saw a couple of different examples of things happening like this. So there may be wireless by another team, a separate team that is mission critical for them, and they want to have that wireless separate from the rest of the IT network. That was a political reason. There was mistrust between the IT team and this team that needed wireless for tools. So they had their own Cisco network again. So there were two Cisco networks in the same environment. They had agreed to put their devices on 5 gigahertz on channels that we were not occupying. There was somehow there was an agreement there, but it was not a good idea to have two wireless networks on the same area. I also saw contractors or partners operating in the same environment, and they needed their own wireless because they need to connect it to their own network and things like that. These are people that are half of the workforce on that plant. A logistics team, for example, is half the workforce on that plant, and they need their own wireless in the offices. And there was no way of getting rid of that either. So you need to live with that interference. So that's why I call it compulsory interference. You have to have it. There's no way of ripping it out. It's not like a jammer that you can just go and disconnect it, or a home router that somebody brought to the office. That also, just take it out. If your policy is no home routers in the plant or whatever at the customer premises or at the office, whatever you are, then just take it out. Now, my lessons learned here, and this particular environment did not have an RF spectrum policy. My lessons learned is, if you don't have one, define an RF spectrum policy. The RF spectrum has become really crowded, as we all know, 2.4 and 5 now as well. We have so many different systems trying to utilize the antenna spectrum. In 2.4, we have Bluetooth, we have microwave ovens giving us interference. In 5 gigahertz, we have radar. There's so many systems there. Just write down documentation that says, okay, if somebody wants to put something on 2.4 or 5, at the very least, you need to document it. Better than that, there should be an approval process if it's something that is going to go in parallel to your existing devices. If a third party requires wireless access, try to put them in your own network and separate them logically instead of having a physically separate network, right? This is not only wireless. In general, in networking, you try not to duplicate the physical network. You try to do smart things on the logical side, just to separate different systems. So my recommendation is the same in this case, because causing additional interference in your RF is not something you actually need. All the contrary. If you have no other choice but to have parallel networks, then try to manage the channels wisely. Try to define some policies to know who can deploy what channels, power levels, things like that. In particular, channels and power levels, those are the two things that you need to define. And if the wireless network that the other party needs can be localized, then just localize it. Make it put the power at the minimum level possible so they can still have coverage. Sometimes there are political reasons that you have to keep the systems. If you need to live with those systems, as I said, at the very minimum, document it. Okay, quickly through clients, because I want to leave Francois as much time as I can. In the manufacturing environment, forget about the tablets, forget about the phones. Those are usually have the latest and greatest 802.11 protocols. In the manufacturing plant, you will encounter handheld devices. I've encountered some very good handheld devices and some really bad ones. In another manufacturing environment, I saw once devices from China, very, very cheap, but they would not reshift. They were 802.11g, and they would jump from 54 megabits per second straight to 1 megabits per second if the signal dropped even a little. So they were actually really, really bad clients. So all the money they save buying these handheld devices, they spent on troubleshooting the wireless connection. So you have these kind of devices that are bad in your network, but you can also have some good ones. We had some good devices in my environment, but still, what I had with them, they were good at roaming, they were good at receiving the signal. But I did notice that the antenna sensitivity was different than the laptop. So, for example, if I was right in front of the IP, the handheld and my computer will show me more or less the same level of signal. But if I was about 5 meters or 10 meters from the access point or from the antenna, the signal will start differing, and it will go from 3 dBm, 5, 10 dBm difference. So up to 10 dBm difference when I moved away. So the way they sensed the signal was completely different to my computer, right? The sensitivity they had. So you need to, when you are surveying or preparing your network, you need to keep in mind the device that you will have in that plant, right? And they could be very different devices. I've seen this card from Cisco in use because in this manufacturing floor, they were using a system that had PCMCI slots for doing stuff what they were building the products, and this device needed a PCMCI card, and of course they use this Cisco Aeronet card, which is not being produced for many years and is no longer supported, but they still had those products there because they needed those devices for the manufacturing process, right? So this card I have seen in use. The car was inside this device, covered with the lid, inside a vehicle, inside a closed and testing area. So on my computer, sitting right next to this card and this device, I will sense minus 68 dBm, while this device will barely see minus 88 dBm. So huge difference. So you have to plan for that device. In this particular case, I recommend a localized coverage. Instead of having a high gain antenna outside, just put an access point closer to where the client is to these devices, and don't provide huge coverage, just localized coverage for that particular area. I've also seen this kind of devices as that you see in the picture on the right in forklift terminals and automatic guided vehicles. These two I've always had very good experiences with them. They will never had any problems with coverage or roaming or things like that. So these were usually very well behaved clients. Now for clients, I already said lessons learned. Calibrate your site software for all the devices to work. Don't use only your computer, right? Take some of those devices with you when you're doing your testing and your deployment recommendations. Localized coverage for weak receivers and transmitters. And skip the roaming part, which was supposed to be skipped. Very quickly, before I hand over to Francois, do not upset the status quo. That's the main thing in the manufacturing floor. These are mission critical networks. companies can lose millions of pounds or dollars if the manufacturing line stops, even for a few hours. Or if logistics are disrupted, as I said, they can affect on the long term the manufacturing process as well and cause losses. Some networks have grown over many years. They can be very mixed and match. So I call this organic growth. You have very old access points with very new access points, and the deployment is completely different from one and the other. So you may need to live with those things and slowly try to migrate things to newer technologies. Big changes are not allowed. We always follow ITIL processes for everything we did, and big changes are prohibited. If you have somebody reviewing the changes that you are suggesting, we had a process of saying, okay, this is what needs to be done. There was a script, then it will go into approval. And if I was just trying to do too much too quickly, they would just say, nope, this is not happening. It's too risky. So most of the time, it's better to divide big complex changes into smaller steps. And of course, before you start, test as much as possible. If you have a lab environment, it's in a lab environment, then maybe try to do a pilot or a deployment in the smaller area. So we had some engineering areas where we would have a sort of manufacturing environment, and I could deploy things there and just try them out or test them out before they went into the big manufacturing plant. Engage all teams. So if you need to talk with the security team, you need to talk to a client's team. In terms of the clients, it's better that they buy good clients instead of them crying over the bad performance. So work with them from the beginning. Tell them, okay, buy good clients, buy clients that support as many 802.11 protocols as you can. That's my recommendation. People usually look just at the speed. They only look at 802.11n, 802.11ac. There's more things than that. Life is not limited just to the speed of things. There's security, there's roaming, there's a lot of other protocols there. So as many 802.11 protocols as you can get. That's my recommendation in general. Sometimes risk must be taken. So you will still have to go and do a change at some point. You will have to introduce new technologies, and you will have, in those cases, cross your fingers and pray to the networking gods that things will go well. So that's all from my side. I will hand over now to Francois. Francois, do you want me to pass you the?
Yes,
I'm
please.
not even sure how I do that. How do I make you presenter?
I can pass the controls, no worries.
Please, thank you.
Can you guys see my screen?
Not yet, I'm
Yes.
still. All right.
Yes, I can see it on my end.
Right.
Perfect.
All right. Thank you, Elizabeth, for the great presentation. I'm going to show you guys a couple of examples. So I picked out two different scenarios. The first one would be mezzanines. So it looks like this. It's usually you have different levels, 2 or 3 usually, lower ceilings, narrow aisles, or narrow or very narrow aisles. Different ceiling structures. Sometimes it's just plywood. Sometimes it's like a mesh metal, ceiling. You usually have limited mounting options. So I'll show you guys how we could modelize this in Ekahau and how we could design for a mezzanine. And then the second scenario would be a typical racking space, distribution center, and how to try to design so it's not affected too much by the amount of stock you have in your racking and by the type of goods you have in your racking. So whether it's something that's attenuates the signal a lot or just something that's not really attenuating the signal. So I'll go into Ekahau and show you guys those two scenarios. All right, so that's the first one. So I pre-modelized a little warehouse. So on the left, we have the racking space, and on the right, where you see the 2.5 meters and 6 TP loss per meter is the mezzanine. So the way you modelize a mezzanine in Ekahau is that you will basically import the same floor plan twice. So you see here I have the lower level, and then I also have the upper level. the upper level is exactly the same picture. I have designed the attenuation areas, so the rackings. And on the second floor, what you do is that you create what they call a hole in the floor right there. And you specify the rest of the warehouse as a hole in the floor. And this way, Ekahau will just assume there's no floor and will just simulate the signal on the lower level. Actually, by the way, there's an article on the support website on how to design, how to do this process. So you can go and check it out on the Ekahau support website. I'm sure the guys can add the link in the show notes. So if we go back to the lower level, I will show you in this example how we could design the Wi-Fi in the lower level. So I'm going to zoom in on the mezzanine. So we have, in this specific case, we have very narrow aisles, and workers are going through the aisles, picking items, scanning barcodes with their handheld device, and they need a Wi-Fi everywhere. If I take a typical omnidirectional AP, like the Cisco 2702, and I try to place it on the in the central aisle, and I look at the signal strength, this is what I will get. So you can see that the signal is being attenuated a lot by all of the racking space. I have set this racking as a 6 dB loss per meter according to a specific deployment I've worked on. But in order to figure out exactly what's the loss of your rack, you will have to go on site and measure it. I like to think that every warehouse is, it's like snowflakes, right? Every house will be different. So when I do design for warehouse, I always go on site and check it out and take some measurement, do a couple of AP on a stick, measure attenuation, so I can import the data into Ekahau if I need to do a predictive. And this way it's more accurate. So if I place this AP on the hallway, which is where it's easier to mount, I can see that it's not really going to meet my requirements. So I can try to take the AP and then place it into an aisle. Right. So. And then I usually copy and paste the APs. You can copy paste APs in Ekahau. You can copy paste pretty much everything in Ekahau. Attenuation areas, walls and things like that, elements in the design. So it looks a little bit better like this. I'm going to add a couple more APs. I'm focusing on the lower level of the mezzanine right now.
Just real quickly to throw in there, if you want more accuracy with like thin shelves or like very narrow shelvings and things like that, you can of course increase the visualization accuracy from the options drop down next to the 2.4 and 5 sliders. Of course, granted, it will make it slower. But if you put it to super accurate, for example, you will get more granularity near those, let's say, very thin corridors or things like that, right?
Yes, exactly. Thank you, Jussi. Something else to notice here, if we go into the options, since I'm designing on multiple floors, I need to make sure that Ekahau is predicting the signal on multiple floors. This is why here I have the ±1 floor prediction tools. So I'm good to go. And when I go into the upper level, you will see that I will see the bleed through the floor. If I go back into that building, I created this in advance, but I have my lower floor and my upper floor, and then I have the interflooring attenuation. So according to what you've measured on site, you can actually set this to whatever you want. And if I go to this upper floor, I can see what type of bleed through I'm going to have from the AP installed below. this is, so you can see that I have quite a few bleed through here. I had scenarios where I even didn't need to install APs on the second level because the floor was not attenuating a lot, and I could just pretty much get the same coverage on both the lower floor and the upper floor. Right, so this is something I would recommend you guys go on site and measure. Try to see if you could use, the APs for both or for multiple floors, or if you need to add APs to cover the second floor. So here, I would need a couple more APs to finish the design. The second floor is actually 6 meters, right? So the eyes are 2.5 meters high, that they don't go all the way up to the ceiling. So I could, if I add an AP here, if I go back to my access point and I add an AP here, by default, it's going to place the AP at 2.4 meters. So here I need to be careful, and since the floor is 6 meters high, I need to go ahead and change the height of the AP. So I could click on the edit button right there next to the radio, or I could go to action and then edit selected APs and then change it there. I'm going to set it to 5.5 meters since the ceiling is about 6 meters high, and then Ekahau will just show me the prediction with the AP set at 5.5 meters, right? So here, if I use an omnidirectional antenna, this height, this is a signal I would get. It might not be the ideal antenna for this design, and this is pretty much my second example. I'll show you the racking. I have another little project file here. And with this second example, I will show you, it's a warehouse with racks, typical racks. I pretty much made it up, but it's about, the racks are 8 meters high, and the ceilings will be about 9 meters high. So it's a typical distribution center with long aisles. I think I set them to, let's measure them and double check, about 70 meters long, just full of goods. In these type of scenarios, I like to use directional antennas, just like Elizabeth. In order to use directional antennas in Ekahau, the pro tip that I use, I usually upload a blank picture. It's just a white picture, and I scale it to something very long, right? So 161 meters here, and then I can add my AP. So if I take the example here, Cisco AP with the directional antenna, I just drop it down, and then I can visualize the pattern of my antenna, right? And then here I can modify both the horizontal and vertical orientation of the antenna. In Ekahau, if you want to modify the horizontal view, you select the little arrows. If I zoom in, you'll see that I have two arrows, a purple one and an orange one here. The orange one is the 5 gig radio, and the purple one is a 2.4. So I can go ahead and change the orientation of these antennas. You will see the pattern changing, right? So this is the horizontal view. If I want to change the vertical or elevation view, I can click on the little edit button here next to the radio and then change the angle. I can either drag and drop wherever I want it to be, or I can enter the degree in the little area here. So if I want a 30-degree tilt, I can just enter it here, and Ekahau will modelize it for me. So this way I can compare different type of antennas. If I'm choosing the antenna, most of the time the client will tell me you have to use this antenna, but when I have the luxury to choose the antenna, I can compare different antenna patterns. In Ekahau, if you want to change the antenna, you click on edit, and here you have the drop-down list of all the different antennas, and you can compare them. Once you have once I have the AP I want, the orientation I want, here I don't have the proper height, so I can go ahead and change the height. Those will be maybe 8.5 meters. So once I have what I want, I just copy the copy the AP, and then go back to my floor plan and paste the AP. And then I can try to visualize how this AP will play in this environment. So here I can see that with the directional antenna, I'll be able to shoot down an aisle, and I can see that the attenuation of my racking will pretty much attenuate the signal, and then I will have nothing in the racks, in the adjacent racks, right? And so in this way, I can start my design and figure out how many access points I'm going to need, where I'm going to need to place them in order to cover the whole building. Here, if I put an antenna on this aisle, I can see that I don't have the proper horizontal orientation, so I can drag and drop the I can just drag the arrow and orient the signal wherever I want. In this case, the antenna I've chosen, it's a single unit for both 2.4 and 5, so just make sure you keep the arrows together so it represents the reality, right? And then I can continue the design and finish it up and tweak it as I want. And then when I'm done and I'm happy with what I have, I can go back into the attenuation area I chose. So here I go back to attenuation area. I select the one warehouse rack, which is the one I chose, and then here I can play with the amount of attenuation in order to see how it will affect my design. So I can set it to something low and see how it affects my design, and then increase it little by little, and just make sure that whatever I'm going to have in my racking, whether it's toilet paper or wine, it's going to be fine. It's not going to affect my requirements. All right, I'm a little short with time, so I'm going to finish it there. If you guys have any questions, I'm sure we can answer a couple of questions. You see?
Absolutely, there's like a boatload of questions for sure. One of the most common questions, did I already forget one of the most common questions? Hold on, let me try and find it here.
Hey, Jussi, while you're finding that one.
Yeah, go on.
This is Jerry. I was just going to ask, one of the questions I thought that was a really good one here was around the surveying an empty warehouse. How do you compensate for, machinery that might be moving around, or, obviously the racking fluctuating and, being filled then afterwards, or, can you, design that when the warehouse is still empty?
Okay, so I can try to answer this one. I've had experience with, I was designing a warehouse for a company that was moving from a different plant, but they were growing, so everything was going to change. And so I asked them, can I see the place? And they're like, yeah, sure, come on. And then I come into the warehouse and it's empty, right? Not even racking is in place. So I asked them, do you have the floor plan and how everything will be laid out? And they gave it to me. I produced a design according to that, and then I went back on site after they installed everything to validate the Wi-Fi, and it turns out that some racking were like lower than what was defined on the floor plan, and a little bit of shifting there, here and there, and so I ended up tweaking my design afterwards. We ended up taking a couple of APs down because we had pretty much too much APs in one area in order to fix the design. So it's always better for warehouses. Anyway, I think it's always better to go on site first and try to get a sense of the environment. Just like David said, it's also a good thing to talk to the people working in the environment so they can tell you how it moves, how it evolves with the time. And then if you have to modelize in a cow, just do, I guess, the best you can and always go back to validate, That's
validation in these environments is always critical. No matter how accurately you model, it's still going to be a model. And tough environments like warehousing and manufacturing, there's no way around it. You need to validate and you need to do a spectrum analysis. I did find the commonly asked question, and it was, how can we model coverage at a certain height? So, for example, if the receiver is not like, the heat maps in Ekahau, we show them at 1 meter height. So we assume the receiver is at 1 meter height. However, oftentimes in warehouse and manufacturing, the receiver is at 2 meters or 10 feet or whatever, and it may be in the ceiling. I mean, if it's a robot, that's just moving in the ceiling or whatever, or high forklift, whatnot. So I don't know if this works already in the current version, but Francois, if you hit Alt and click Options, the visualization options button, hold down Alt and click that. Okay, so clearly it's still not in this version, but it will be in a future version. So it already works on my development build here, and I think 9.1 beta probably has this. So if you hold down, sorry, did I say that right? I think it was Alt. Yeah, if you hold down the Alt key in the future, you will be able to set the receiver height.
Oh, it's Command. I was able to get it with Command, yeah. Command,
all right, very good. I just tried it, and yeah, that's right. So the Command key on Mac, and I think on Windows, it's something similar. So just hit the Command key. By the way, this hasn't been told publicly ever before. So if you want to visualize the heat map from 5 meter height or 10 meter height, whatever, hold down Command Mac, and I think it's Control or Alt in Windows, while hitting the options, and you get the extra setting of visualization height. It's a hidden feature, and it's not in a way public. So if it doesn't work, let us know how and why it doesn't, and we'll fix it. Jerry, Joel, Francois, were you aware of this thing?
I had no idea about that one.
I was aware it was in development, but I didn't know it was hidden like that.
Very good.
It's good to know.
Then there were questions on how can we model high environments in Ekahau, and I think you kind of showed that, but by default the buildings are fairly not very high. So I guess this question was more for like a multi-floor view. So if you go to building view, Francois, that's where you can construct the entire building. For example, if you choose those both of those floors, holding down Shift, there you go. So that's when you kind of get the side view of the building, and then you can set up, the materials between the floors and the height of the floor and the height of the floor material that's between the floors and things like that. So that's kind of how you construct an environment, whether high ceiling, low ceiling, whatnot. And can you also show real quickly, there was a question on how to do exactly that. So walls with height and attenuation areas with different heights. There you go. So if you click the cartwheel next to the selector of the material, then you can select the wall height and also the height from the ceiling and the attenuation of the wall, so you get the full control of the wall materials. And then there's a question of any mass editing for wall and AP height. So mass changing back to default, things like that. So wall heights, you can edit all of the wall material from here, where that Francois is showing. So all of the warehouse racks would be changed to this height. So that's kind of the mass editing there. Francois, can you also show how to mass edit access points? Going to the access point list, and from there, if you want to edit all of them, you could say actions select all, and then actions edit selected simulated radios. So that would give you the opportunity to set the height of every single AP or selected radios or just radios with certain parameters to set the height. And then there was a frequent question on how do we get antennas in that are custom. So my antenna is not in the list of your enormous database of couple of thousand antennas. How do I get that in there? Jerry, how do people get antennas in there anyway if they're not on the enormous list we have?
I think they email UC, don't they?
Yeah, Jussi at ekahow.com, right?
No,
But this is
support.
always the
Yeah, support at ekahow.com would be the best resource for that. But yeah, like UC mentioned, it's a very extensive list, and every time you update the Echow Site Survey application, that database is also updated with all the latest and greatest gear from all the vendors. So yeah, first and foremost, make sure you keep your Echow Site Survey up to date, and then yeah, for some reason a model antenna is missing out of there, shoot an email over to support at ekahow.com, and they can get that added to the list.
Exactly. Then there was a question of, you know, these weaker devices. So if you survey with a Wi-Fi adapter and you want to emulate a weaker device, how do I do that? And today, the options menu does provide something for that, but I don't recommend using it extensively for you know, it's just not. It's a bit outdated feature, to be honest. However, version 9.1, which will be out in a few weeks, will have a DB compensation feature with some predefined prefixes, if you will, or predefined client devices. So you will have an easy way to offset to compensate for, you know, low quality radio devices like barcode scanners and cellular phones and tablets and things like that. So wait a few weeks, and that feature will be there.
I can tell you what I used to do. I can give you what I used to do. I would, because the difference between the device that you're using and your Ekahow card and your site survey laptop may not be constant. That's the problem that you have, and why it would be good to have a model, right? And that's why the feature that Jussi is mentioning, it will be very welcome. The difference may not be constant, because the difference was not, there's no way of modeling that. What I did is look for the worst scenario. So with my handheld, if I was right next to the access point, as I said before, the signal would be the same. So I would walk around with both of them, comparing signal levels, and find that worst case scenario. And I said, okay, in the worst case is 10 dBm difference. So I will survey 10 dBm higher for my coverage. That's how I compensated for those handhelds. It's not the case all the time. As I said, the modeling of that device receiving signal is different, that the kind of the pattern is different and as the laptop. And that would be fantastic if you could model that the actual client receiving. But at the very least, my easiest trick was just push the boundary up by as much as my worst case scenario, because I had to ensure that device had signal absolutely everywhere, even in that worst case scenario.
Thank you. That's great advice right there. Then there's a very, very frequent question of, will this presentation be available for future views? Nicole, that would be for you if you're, sorry to throw you under the bus all of a sudden. If you're there.
No problem at all. Yes, we're recording this session. It'll be sent out to everybody who registered within the next 48 hours after the conclusion of the session.
And then there was a question, any link where I could buy an AP on a stick? Now, Jerry, your buddy Nick does this stuff, right?
Yeah, Nick Turner, one of our other SEs, has a great blog post on if you want to be a Wi-Fi MacGyver like Nick here and build your own AP on a stick. He's got a great tutorial on his blog. Let me look up the link to that, and I'll put that in chat.
Yeah, that's great, because I don't know how many there are that are readily available and awesome. Isn't there some kind of an AP stand now from some vendor? Which one was it again? I don't recall.
You talking about the Wi-Fi stand?
I guess.
Yeah, the WiFiStand.com, I believe it is. I'll look that one up as well and put that into chat here. But yeah, there's a few options.
Okay, there's while you're doing that, the next question is, and there's several of these, like dynamically changing environments. You know, machines coming and going, and shelves coming and going. Elisabeth, Francois, Berger, any advice for dynamically changing warehouse manufacturing environments?
I would say plan for the worst. So design for the busiest time, design for the most occupied space that you can find, and leave a spare power. Now, stay away. That will be regarding coverage and power, and also stay away from all the areas where things are moving. So try to find, for mounting, right? Try to find the best location for your antenna, that it will not be knocked, that it will not be moved because somebody decided, okay, we cannot put this here anymore, and that it will be also not be covered, because if you're putting it right next to something that will then be covered with racks in front of it. So it is very difficult in that very dynamic environment. I found it very difficult working with somebody that knows the processes and the work of the plant was the best solution, and they would tell me very flatly, they will tell me, don't put it there, it will be hit. Or they will tell me, we need to put it at 10 meters, there's no choice because we don't know where the rack is going. So somebody that knows, and then you have those limitations, and when you are designing the coverage, leave some spare room. Design for the worst and leave a spare power left. That's my very simple recommendation.
I like that.
It's not easy. What I would add is just in warehouses especially, just make sure you understand the antenna you're using, the antenna pattern, how it's gonna, because that's something we don't see, right? So it's not easy for us to grasp, but just I guess you can use it how to modelize and understand better the antenna you're using if it's not an omnidirectional antenna. And like Elizabeth said, plan for the worst. Something else I would add is make sure you understand where the clients will be used. I had some scenarios where the clients were used under the racks. They had little galleries under the racks, and workers would go under the racks with their guns and start scanning. And they were, surrounded by milk. So, and they were not using the right type of antenna in this scenario. When I was just coming to troubleshoot, all we did basically was change the type of the antenna, and it fixed the issue, right? So just make sure you understand the type of antenna you're using, the propagation, and yeah.
Very good. Interesting question. Elizabeth mentioned WearNet overlay for track and trace tags. Do you have any experience when using Wi-Fi tags from AIRS, for example, and Cisco, MSC, CMX, in terms of accuracy, AP deployment, etc.? We could have, I think, 30 different webinars out of this subject alone, having designed and deployed.
So do you want the theory response or the practice response? They're two completely different ones. The practical one. So I'll tell you an experience of one test that I did in a kind of office space. We managed to get an accuracy of about 3 meters. Those were 5 access points in a very confined space. Very expensive, not realistic to deploy. Now, with a more realistic kind of deployment, my experience is if you do it right, if you do a good deployment, tightly packed as per location recommendations, you will probably get 7 meters to 10 meters accuracy. More than that, it's gonna cost you money. It's gonna cost you money. As I said, we managed to get in a very small test environment 3 meters, but it was completely impossible to deploy that kind of density in the way that we did in that test, right, for huge areas. And in a manufacturing floor, as I said, the spaces, at least my experience was, it was a huge area. There was no way somebody was going to give me the amount of access points I would need for the accuracy. For that kind of a space, I think the best you can hope for is nearest AP. That is realistic, right? You try to pack them close together so you have a spare power, so you're not pumping everything at maximum power, so you're either power level 3 or 4 as per Cisco standards, or something like that. And your coverage for one AP, maybe, I don't know, 10, 20 meters radius, and you can then say, yes, I can easily do nearest AP. That kind of applications, and you have a use case for that, that will work. That will work always. It will be fine, right? If you are committed to a business case of saying, okay, yeah, we will track something to one manufacturing area or another, then that will work. you want to find one device, whether it's in building 1, 2, or 3, that's also possible. But if you want to do that kind of accuracy of 3, 5 meters, it's going to cost a lot of money, and I'm pretty sure that in the manufacturing floor, nobody will approve that. So don't my advice from the practical side is don't overestimate what you can receive. If you're realistic on the accuracy level, you will do fine, but you need to be realistic about what you can deliver with that. Yeah, that was the practice response, not the theory.
Amen. Amen. I mean, expectation management when it comes to RTLS projects is crucial.
Definitely.
And while people will tell you that, in a hospital they got 1 or 3 meter accuracy using ECHO or AirScout or systems like this, it doesn't stand for warehouses. Like Elizabeth said, in warehouses, 10 meters or 35 feet is a more likely accuracy. So don't fall into the trap of it worked great in an office environment, so it has to work better in an open environment. It doesn't. It works worse when it comes to Wi-Fi based RTLS anyway. Of course, then there's TDOA and ultra wideband, and different systems work different ways. When it comes to Wi-Fi based location tracking, it's the more closed the environment, the more dense the AP setup, the better it works.
Yeah, in particular, if you're only using the basic RSSI radios, so the distance based on power level, that's when it becomes very unpredictable in the manufacturing floor, because you have big absorbers, you have big reflectors, and your power levels are just all over the place, so you cannot rely on them very much. TDOA improved that as a technology, right? It gives you additional information, but power levels fluctuate so much that it becomes very difficult to have accuracy in those spaces. Yeah.
Exactly. Then there's a good question from John. Touch on providing access outside the building or extending from building to cover outside to another building. I think this probably calls for another webinar. What do you think, the whole outdoor coverage and things like that? It's a pretty wide subject by itself.
Yeah, usually what I would do is keep the AP inside, and then feed the antenna cable through a hole in the side of the building, and then only install the antenna outside, and then try to use directional antennas and try to tilt the antenna so it covers whatever you want. Sometimes it's not enough to cover the outside of the building, and so you'll need to create like a bridge or a mesh network if you want to cover wider areas. Like you said, it's a whole other subject, just like a location. So you could probably have webinars on that as well.
That is precisely what you just said. That is precisely what we did. We, most of the time, if it was an adjacent area to a building, we will place antennas inside, antennas outside, access points inside, sorry. And there was only one case where we had a proper mesh deployment with full outdoor access points, which are much more expensive, and you have to have the business case to deploy them. It was a parking lot. It was a huge parking lot, really completely. It was like 2 kilometers by 1 kilometer, completely open, only power every now and then, and that was a full mesh deployment with outdoor access points. If you have any buildings adjacent to the area you need to cover, what Francois said works very well.
Excellent. Then there was a question on, I know we're significantly over, but I don't harm in going over unless Francois or Elizabeth, you need to go. And I understand, so let's wrap up in a few minutes, but one question was about the directionality of the antenna. Let's say high ceiling environment, highly directional antenna pointing down. Certainly the AP will reach the client at reasonable power levels, but does the client back to the AP if you're just using high directionality antenna around? But doesn't it work vice versa as well? It will be better at receiving and transmitting.
Yeah. So in this case, what I like to do is I always like to do packet captures and check the amount of retries I have. Try to see if I could have this potential type of issues, and just I also never use the maximal transmit power on the APs to minimize this effect.
Yeah, you don't want to go with the power too high. And now with the directional antenna pointing down from the ceiling, you will actually not be too far from the client. It actually is not, you may think that you are too far. Well, what I had was either high gain Omni or high density at 10 meters. The high gain Omni will have worse coverage at the bottom, at the floor, but they will be in both cases, they will be the same distance from the floor. So they will hear the client just the same, right? And that will be the same. Now, handheld scanners had no problem in either of them. I did have weak clients, and for the weak clients, I couldn't provide coverage in that way. I need to have localized coverage for those particular. But luckily, in my case, those were particular areas, very, very determined where they were. This kind of clients. So I was able to tackle that area in a different way that I will tackle the rest of the plant. But yeah, you're quite right. You need to make sure that the client can transmit back to the antenna.
And for speaking of transmission to work, there's been some questions about the metrics. So you mentioned retries, right? So what metrics besides signal strength are important to observe in a warehouse environment? Let's say when you do site surveys and when you do troubleshooting.
I look at signal strengths, SNR. CCI in a warehouse environment, like Elizabeth said in her presentation, it's less of a concern because usually you don't have a high density of clients. It's not uncommon for me to see warehouses with more APs than clients. So you won't have a lot of CCI issues. But yeah, so I look at signal strength. Signal strength is very important. SNR, and then if you do troubleshooting, look at the retry rates. Look at the if you can look on the devices directly on the barcode scanners on the lift trucks, embedded computers. If you can look at what they see directly from there, it's great. Some of them have great Wi-Fi applications where you can actually display all of the APs that you see, the different levels, the AP names. If the AP supports AP names, so it can help you to troubleshoot. When I troubleshoot, I always ask the customer to give me one of the scanners, so I can just walk around with it and see what I and troubleshoot what I see from the scanners. Also, sometimes if you have a lot of metal, a lot of reflections of the signals, things you don't see, but that will generate retries. I've had issues with older clients not supporting MIMO, and that would impact the retries. So yeah, try to check those metrics. I think that's the most important.
Yeah, well, I would add only one thing to that. The one thing that I had a lot of problems, a surprisingly high amount of problems, was with roaming. So I will perform a roaming test. I will try to simulate the past and see how clients will handle. So apart from having coverage everywhere and having the good SNR and all of those things, I will just walk with the client around and see how it will roam. And I was surprised because most times the problems were actually associated with roaming, not with anything else.
All right.
Yeah, and sorry, I was just going to say on roaming, if you have the luxury to place the AP wherever you want in the warehouse, try to think about roaming as well.
And what is an acceptable retry rate or packet loss in an environment like this?
Sorry, Jussi, I didn't hear the beginning of the question.
So do you have a ground rule for an acceptable retry rate or number of retries in this kind of environment, or packet loss percentage, or?
Well, this usually depends on your requirements and which application you're using.
Let's say for
Um,
voice.
Voice usually a lower retry rate, so lower than 5% would be good. Sometimes in these environments it's not possible. So what I would do is I would just test it. Just take a VoIP phone and then initiate a call and then walk around in the warehouse and make sure I have a good user experience.
And speaking of rules of thumb, there was a question on, is there a rule of thumb on when to use external versus internal antennas? Is ceiling height the dominating factor? And like, if so, where does the threshold go? Like how high does the ceiling have to be so that you switch from internal antennas into external ones?
Yeah, so the decision factor is usually money, but after you pass money, I would say I would say anything over. I'm trying to think in feet versus meters, but anything over, I would say 20 feet, I would start using directional antennas. Um, yeah, that's usually my rule of thumb.
Very good. Okay, I mean, we're already 30 minutes over, and out of courtesy for the presenters, and also to let the audience get back to work, we still have we're 30 minutes over when we still have like 500 attendees on board. So you guys certainly kept the attention going for a lot of folks. So
Very
thank you so
committed wireless
much.
engineers.
Thank you so much
Committed
for
to the
joining,
train.
Elizabeth and Francois, and the recording will be available. Nicole can fill that in, but on my behalf, thank you so much for coming. It was just another fabulous webinar, guys. I don't know, thank you enough.
Well, thank you for having us.
Yes, indeed.
And thank you for the audience, and Jerry and Joel and everybody for joining.
All right, yes, and as UC mentioned, you guys will be receiving an email within the next couple of days that will have a link to the session, but if you have any other questions, feel free to reach out to the Ekahau team. Thanks very much, everyone. Have a great rest of your day.
Thank you so much. Have a
Thank
great
you.
day.
Bye-bye.
Cheers. Bye-bye.